Thank you for inviting me here to give this presentation. I hope it's useful for you. I chose a slightly provocative title, which is perhaps suitable for this kind of event, and especially because we are at Chalmers. Okay, so first of course, we have to go into the normal story of what EOS is all about. Being one of the remaining independent companies in this business. So EOS was founded in 1989 to develop a European-based SLA technology. So we have been in the business already more than 25 years. Of course, it was not called additive manufacturing at that time, but the same principles apply. Everything has gone further. But it's still kind of the same legacy what we are working with. The most important thing on this slide is of course the text. Nice people also visible. That's top management of EOS, and Hans Lange in the middle, who is the guy who founded EOS 25 years ago. So the purpose was, as I mentioned, to develop European-based rapid prototyping. So it's still family business, real family business. So Hans Lange with his family owns the whole thing. And we want to focus on solutions. So we don't want to sell machines. We want to enable solutions for customer use, because that is the way to manufacturing, and the manufacturing, at least from our philosophy point of view, is the one of the most probable sustainable ways to be in this business. So we operate in variety of industries. Basically, the application field is limitless. In practice, this causes some problems also, because here we have to deal with several different kind of industries with all the different requirements coming from these industries. We are committed to innovation, quality, and sustainability. Sustainability comes from the family of the owners. They really live sustainability also in their practical life. So the size of the company, the last completed year, announced year, was 350 million euros. So we are reasonably sized, but of course nothing compared to the operators that very likely will enter this business within, or are already entering this business. But we grow fast with of course some hurdles on the way. So we are about 1,000 employees. We are a global company. We have sales and service offices in 11 countries. And we, in addition to that, we operate with 67 distributors worldwide. So we, as a relatively small company, we can cover the whole globe. And that is the only way to manage, of course, also manufacturing. With all these different offerings, not only sales but also service has to be global in manufacturing. That's one way of describing the size of the company. We have about 2,400 systems installed worldwide. Not all of them are operative, because some of them are really old. Maybe some of them are already in museums. But still, it's one way of describing the spreading of the technology. 40% of these are metal systems and 60% are polymer systems. There's a natural reason for that too, because polymer systems were there first, and the metals came a little bit later, and also the application fields are slightly different. Because plastic technology is still used a lot in prototyping, a little bit in manufacturing, and in metals it's vice versa. Okay, so we are experts in plastics and metal AM technology, and we want to we want to innovate with quality, because the quality is the key to manufacturing. That was already chosen as our guideline already years and years ago. So, and our mission is to provide industrial grade materials, systems, processes and services. So not machines, but solutions, and also services around the solutions. Our vision is that additive manufacturing technology is an established and efficient way of industrial production. So this is our vision, this is what we are aiming for, and that this is our driver. We do our decisions based on that. So now we go in materials. So I'm a materials guy. I have worked with metal powders all my life. And also because I have a dual job, I have a corporate job and also a local job, which is located in Finland, and that's all metal materials. So our way of introducing new materials in our systems is that we don't sell powders. We want to connect the powders with the machine, with the process. This is what we call a holy triangle. So, because we are very much concerned of the part properties, we believe that also our customers are interested in the properties of the parts coming out of the machine, not the machines itself or necessarily the beautiful packages of powders. So we have introduced this kind of materials to the marketplace, fully understanding that the world contains hundreds, if not thousands and thousands of different alloys. But because we want to make the solution work, we do this carefully. We don't launch powders, we launch materials with properties, identifiable properties. This is a little bit of the timeline. So before 2004, it was the era of kind of old, previous generation technology. It was CO2 lasers, and they perhaps also not all the other components in the machines were not fully matured. I'm not saying that they are even today fully matured, but much more matured. So in 2004, fiber lasers were introduced, and this opened us a completely new world, because in principle, we were able to process whatever material, all metals and even ceramics. And after that, we have launched all these material groups. And how we do that is, of course, that because we are a small company, we have to listen to our customers. So we take the voice of customer before we start anything. And then we develop our solution triangle together with our supplier network. We have several suppliers for powders. I would rather call them partners than suppliers, because our relationship is very intense. We want to help each other, and we don't go into price competition easily. And we offer the customer value, which contains kind of control of raw materials. This is a very often underestimated thing. How do you control your raw materials? Because it's not about particle size distribution, or it's not about chemistry, because there's much more things in powders than these. And a lot of them is kind of in a gray zone. Nobody really knows how to specify a perfect powder for a certain application. So our way of doing this is that we have partners, and we take control of our partners. And this control will transmit to our customers also. And we collect data all the time, so we know how our suppliers behave. Of course, the lot traceability and the flexible volumes come with automatically in the question, because this is the customer demand if you want to operate in this business. There's all kinds of customers, very small service bureaus and also large OEMs who have a little bit different requirements for their materials. So, as I mentioned, we don't do parameters, machine parameters. We offer validated processes. We have internal testing standards and standard operating procedures. How do we do that? And we have categorized our offering in technology readiness levels nowadays, because that's kind of the language what is known to industry. And we offer at the moment two different main categories. What we call core is the less mature processes, and then we have full industry line process or solution products, which kind of we would put in readiness levels 7 to 9. That's a little bit complicated picture. I don't think we should go through it, but it's a brief description what readiness levels might mean for us, and also that what the customers would then get from us if we should go in discussion. So, because there's different demands on the market, not everybody wants to have fully developed processes. Some people want to have something less or a little bit more flexibility in the further development, but we want to enable them fast in acquiring the technology. And technology TRL levels is one of the tools that we use for that. So, what is EOS Finland? So it's a materials and process development competence center of EOS. It's located in Turku, Finland, Åbo. From Stockholm you can take the love boat and go there overnight or overday. I'm the general manager. It's about 65 people. It's R&D, about 24, and then we have metallurgy lab, quality team, supply chain, procurement, admin, and quite a bit of temporary workers. So we are dedicated to develop, procure and supply high quality products, metal powders and processes. So we take the German machines and make them work in a way that the outcome has properties that our customers want to have. So we create a specification, material procurement, packaging, labeling. This is the supply chain work, and this is considered to be the core competence of the success of the complete EOS group. So, why do we exist? Why does a German family-owned business have a subsidiary in Turku, Finland? There's a natural reason for that if you read it there, because the metals technology was developed in cooperation. So we approached in the beginning of 1990s EOS, because there was already some metal powder know-how, materials know-how. We approached EOS and let's put our competencies together and develop a system first, and then these processes to use only metal powders. So put in metal powder, get out metal parts. This was unique at that time because this kind of things did not exist at all. And as a result, in 1994 or 5, the first commercial system in the world which utilized this principle was introduced. So later on, it was part of Electrolux. Later on, Electrolux decided that this is definitely not their core business. And after some complicated actions, the EOS acquired the development group and set up the EOS Finland as a company. So first in cooperation, then inside EOS, doing basically the same stuff. So functions: global sourcing of metal powders, metal powder manufacturing, what we call manufacturing is usually mixing and the packaging and the labeling and such. We don't have our own powder making capacity. And development of metal process products, and the process is the software product, if you like, which connects the powder material and the machine, specified machine together to make the solution. And we work, and everything is commercialized through the main organization in Germany. So we have we have a couple of quality systems in place, 9001 and the medical one, 13485, because we have developed the additive dental solutions for EOS. So they are actually Finnish solutions operating in German machines. So with that, to be able to do that, you have to have the medical quality system as well. So, going back a little bit to the offerings, as I described, and the TRL levels, to be able to satisfy then the need for in the market, we have sectioned or divided our offering in 3 different groups. We have, I'm talking about now R&D related actions. So we have the conventional metal materials and processes group who fully develop powders and process and put them together and offer the solution. And we offer also validated material properties with all the statistics which go into the statistical proof that the case really is as we say it is. Then we have the medical applications development group, which in addition to the previous one also offer authority approvals in the region that we want to do business in. And then a new thing what we introduced this year is custom materials and processes. That is a special group, a kind of R&D people working in a little bit different way, working with customers to initiate something completely new. If somebody wants a new alloy to be developed, so we go in that and make the TRL from 1 to 6 work, and also connect this to the powder offering, and offer this kind of project to our customers. Okay, so we have a lot of machines to be able to do that. We have basically all the commercial ones. It's a really large machine park. We have a lot of 290s and 280s and even 270 machines, M100s, and both kinds of M400 machines. I won't go into the definitions of what the machines are, but I'm sure most of you know what these machines are all about. So, and in addition to that, we also, of course, are very, very much concerned into controlling of the process. That's why we have melt pool monitoring systems and also OT monitoring systems where we get information from the process. And then later on connect this into behavior in the materials, maybe defects, and one day, maybe one day, closed loop control of the process. Of course, we have no conventional heat treatment machines, heat treatment furnaces to do the full metallurgy, because heat treatment is very, very much in our scope also. A little bit of examples, that's how R&D dungeons look like. I'm sure many of you know how they look like. So small rooms full of machines. And that's a glimpse of one of the big machines. Okay, so I'm very well in time. Yes, but that's all I wanted to say. Thank you.